Hello and welcome to Olympus Mons Tutorials. I think this is our fifth live stream, and we're building a game engine. So today I thought what we're going to do is we will start working on our scene class. We're going to need a way of loading a scene and adding UIs to the scene that we are loading. So I think that's probably what we're going to do today. So first thing I'm going to do is I'm just going to quickly drop a message in the Discord channel just to let everyone know that we are live. Can we get a link here? I should have done this. Right, okay, so let's have a look. So the first thing we always like to do is just run our code at the very beginning of touching it, just to make sure that it is actually working. There's no reason why it shouldn't be working, because I haven't touched it since last time, but it's always a good idea just to make sure for definite. Let's have a look. Yeah, the Ether engine, Adam. That's what I'm calling it. If you're asking why Almond engine, it's very similar to Hazel engine and everything that Cherno does. Very nut related. I thought the Ether because it's kind of fantastical. It's also what we used to believe makes everything. So I thought the Ether engine was a good choice for an engine name, and I've not seen it used. Maybe it'll change at some point. I've got a couple of different engine names actually. One of my other ones is called Mage, and that one's for multiplayer advanced game engine because it's a very fantasy engine. Right, okay, so what we want to do is we want to come in here and we want to just create our scene class. I'm going to do this very basically first of all. I've actually been working on basically a copy of this engine that I made myself just so that I could work on it outside outside of the actual time that I'm recording, because I realised that I wouldn't actually be able to pair up me working and the times that I'm recording, so I've actually been working on a separate one. And I've got quite a lot of this done already. I'll load it up if I need to, but I don't think I'm going to right now. No, Almond is a nut, Adam, and Hazel is also a nut, I believe. Yeah, Yan Chernikov is good. If we think of the same person, I think. Although Yan Chernikov is the Cherno, isn't it? And then we've got the other guy that does Ludwig. I can't remember the name. If anyone can remember, put it up on the chat. So before I get stuck on just talking all evening, it's traditional at this point that I ask everyone in the chat what they are currently working on. Tell us about your projects. So let us know. This scene class is I'm just going to keep it as a scene class. I'm going to keep it really simple until we need to do otherwise. As such, I think the only thing I'm going to do for now is I'm going to put a public constructor in here. And as I say, because I've been working on the other engine, I've got quite a lot of head of where we are on this engine, because that was probably 20 hours of coding instead of the 2 hours that I put in on the stream. So I'm quite far ahead of this, and I really haven't been making the scene class recently. So this is very new in my mind, even though I've just done it in the other engine. So we want our scene class, that's fine. What's wrong with that? There's nothing wrong with that. Let's put a destructor in here as well. Let's just create those. And I think the only thing I'm going to do for right this moment in time is I'm going to put a class in here which is I'm gonna put a name in here. That's what I want to do. So let's go W string. Let's go const W string. No, we don't need any of this. Just need a W string, and we'll call it name. Underscore name. Perfect. And then we'll take another W string. This one we want it as a const W string name, which means every time we are creating a class, we need to give it a name. So did I create these? Let's open scene in here as well. I'll tell you what we're going to do is we're going to close all of these windows. We're going to move this into the correct folder. We're going to put our namespace in here like so. A little bit of feedback, guys. I've seen a couple of videos recently. Some where it's very active and we're talking, and some where it's more of an ASMR. I shut up and code, and you just watch with some fancy music. So let me know what your preference is on how this works, because I think we're both kind of new to this. So if you think that this is too much waffling, too much talking, let me know. If you think there should be more talking, also let me know. If you type in DirectX 12 tutorials, I believe you'll find a gentleman called Ludwig that does German and English tutorials. And he does a introduction to DirectX 12, and it's quite good. Good as in everyone gets you to the point where you can render a triangle and move it around the screen. That type of good. Because there's not many advanced tutorials at all available. Right, okay, so I've got a scene class. We need to initialize underscore name. Possibly, Adam, possibly. It's a little bit difficult to check what's what in people's names when I'm coding at the same time. I'm sure people don't want to see me just going in and looking things up on YouTube the whole time. So we've got a scene class, it's got a name, and we transfer the name of the constructor. Excellent. So in our application class, we probably want a way to be able to mark to is that because I can't spell unordered? Probably want a way to actually store our scenes. Let's come in here. Let's just add our. We got list in here? No, we don't have list in here, so I'm going to put list in here. I like list much more than I prefer on an unordered map, but unordered map will do us good right now. Unordered map. There we go. And it's only got 1D. Who would have known? Unordered map. And it's going to be our scene class. And we're going to just call this scenes. You don't know what a scene is, so let's just create that in here. Let's go class. Yep, class scene. Which, for anyone who doesn't know, that means we can declare it here as long as we're using it as a pointer. I am just getting a drink because my throat is a little bit croaky tonight. Scene, scenes. What's wrong with this? Too few argument. Oh yeah, of course we need it to be a double string as well. We need to name the thing. So every time we create a scene, we can create the scene with a name, and then to access it from this list, we can use the name to get the scene. Perfect. Let's create another public function in here, and let's go. What do we want to call this? Probably void. Finding the power of CMake. Well done, Thomas. CMake is something I sometimes use, sometimes I don't use. I kind of use it for when I need to, but I really don't like relying on it for every single project. So Yeah, I'm a little bit of mixed feelings about CMake. It's handy, I understand why we have it, but setting up every project to use it is just cumbersome. Um, add scene. And we should take a scene variable for this. Now, the reason I'm making a big point about being able to make a scene, as I say, we want to be able to make some form of HUD or UI class that we can render in-game, but also to be able to move much further with DirectX 12, we need a container for all of our objects. I don't think I'm going to go immediately onto the idea of ECS, that's in, Entity Component System, on the idea that we're going to make everything super memory fast. I'm just going to make it work for now. And we can come back and add in with that bit later. But I do need a place that we're going to be able to keep all of our objects. So for example, if we load up a triangle, I'm going to need to run a load scene function to be able to load up that triangle, load up all of the shaders, heap files, descriptor files, pipeline, render state, and all of this for that one triangle. So we need somewhere to be able to store it, and then we need to be able to hit load, and then whatever goes in that. So on the idea, if we have a triangle, then we're going to load a triangle. But if we have an entire remap of Los Angeles, that is also going to load at the beginning. So yeah, let's do this. So again, stop waffling. I just want to keep you guys knowing what I am doing. So let's have a look. So we should say m_scenes scene.name. Scene.name. Let's create a accessor for that. Family string name. Don't need to give it any fancy return calls, I don't think, because we don't actually want to access it, so we don't want to change it anywhere. We are going to need to put our include in here. Do you ever get that thing when you're watching a tutorial, especially a coding tutorial, and they go so slowly, and you think to yourself, I quite often just speed them up. So let me know if you think that this is too fast. This is good. Any feedback at this stage will be good, because it can mean I'm retaining viewership from you, and also we're making this a place that you can feel comfortable in coming and hanging out. Equals scene. There we go. So if we hit add scene, we can go m_scenes equals scene. Okay, perfect. Now what does this do for us? Not echoes, that's the game. Let's get rid of that for a moment. Let's build that. Let's get rid of engine DLL. I'm not going to focus too much on the editor right now. I don't really have anything to edit. I'm kind of just adding. So as soon as I get something that I want to edit, I'll work on the constant buffers, which is what you need to make objects move. And once I've got all of that working on this version of the engine, then maybe we'll look into the editor so I can make a nice pretty slide bar or some inputs so that we can change that in real time. But for right now, I don't think we need that editor, so let's keep working on the engine. Right, okay, I've just built that. The engine is in here. The reason I wanted to do that is so that we can go into our echoes now, and we can create ourselves a scene. And we're going to create ourselves a scene in our application and our actual game class, because this is where we would interesting. I'll tell you what, let's not do that. Because I think one thing we're going to need to do is test scenes. For example, change a box. And the minute I put that in echoes, I'm going to end up deleting it later, because it's I'm going to end up deleting that later because I don't want it in the main game. So let's just, but I'm not necessarily going to delete that from the engine. So, test scenes. Nope, we want a folder. Test scenes, and then I can run something fancy saying if no scene is added, add a test scene. What do we want? We want just model viewer. So that we can get all the way through initializing DirectX 12 whilst whilst doing that. And what I might do, I'm going to put it both in here. Let's put our namespace effort in here for now. And what I might do is I really want two scenes so that we can demonstrate moving from one scene to another. So what I might just do is model view menu scene and just put both of them in here so that we can add a UI, we can make a little menu, and then we can go through to the model viewer, and that will give us the ability to change, reload scenes, etc, etc. Perfect. Now we've done that, we are going to need to include our scene. It's in here. Python as an option for scripting comes up a lot. I kind of like to be able to script directly in C++, if I'm making the C++ engine in scripting, but Python does come up a lot. Lua is the one that I'm most familiar with for scripting, to be honest. I used that a lot back in the day. So we are going to need our scene class. Our model view scene, this is the scene. This is a public scene. Yeah, again, Lua is just easy. That's a lot of performance overhead. Possibly so. Possibly so. I haven't checked into it that much. Really, the one I used to use it was for one of my old online text games, which I still do, but where I build quite a lot. And they really don't take up a lot of overhead at all, so you can really get away with not caring too much about speeds. Okay, we have a model view menu scene and we have a model view scene. Okay, let's come back into our scene class and let's add... No, let's not do that. As I say, I've been working on a different engine. And that means I don't have a perfect model for what we're doing tonight. I just thought I'd get on and let's see how inspiration goes. As I say, I think if you're making a C++ game, unless you're really trying to cater to your friends or your people who are making the engine with you, then you might as well just be making it in C++. The only reason to change it away would be if C++ was too complicated for the average coder and you needed the average coder to work on the scripts for you. Other than that, if you're making it all on your own, you might as well use C++ because you're already using it. Right, okay, so let's have a look. I don't know what I'm doing here, so let's just move on. Let's go to our engine class. Everything is fired up here from our engine class. We have our window initialize. After our window initialize, we are going to want to load scene. So let's go into our graphics, DirectX 12, come into our render window. Let's add another. Let's move that down completely. Let's add another function in here. This one's going to be public. Yeah, these are all public. I think probably we could go away putting quite a few of these into private, but we can do that later. Yeah, again, it depends who you're catering for, Adam. I do agree. C# is a good option. But if you're writing your engine yourself in C++ and you're making your game yourself in C++, you might as well just follow what you're doing already. What do I want? I want load scene. And if we're making a load scene, we probably want a unload scene. I'm not putting any entries into this because I expect to have our scene list in our application itself, so we can just draw directly from that. Load scene, unload scene. Yeah. Yeah, C# is easier for beginners. I do agree. You don't have any point of allocation or dynamic memory to worry about. Although I like C#. I quite like going into C# just to chill out for a bit. But right, we can name these in here, can't we? We can go. What's it called? Oh, I don't need a GUI. You should see. I literally built WPF this week from scratch. I don't see why you need to. I mean, it makes sense why you would want to have the ease, but I mean, if I just wanted a free UI that was a free UI, then I'd just go to IMGUI. Or UWP, WinRT, something like that. There's always an option. But the idea of doing everything in C#, again, is limiting. I think that always the objective is to do what makes sense for your game at that time. Don't have pre-opinions on how things should go. Just do what is needed at that time for your game. One of the things I like to say is stop making a game engine and start making a game. Because a lot of people spend a lot of time, all of us in fact, trying to get a perfect application working, and then you can always keep making something better. And that doesn't give you a clearly defined goal to reach to if you just keep pushing and pushing. Whereas if you say I want to make a game and you start focusing on a game, you have direct, specific goals that you can reach for. Okay, I just wanted to do that just so that we won't get any errors. The Mars security services are on full tonight, so I apologise for that. So, temporarily, where is this? This is in the engine. I can access it from here. It's fine. Right, okay, so let's put our temporary scene in. Core. Test scenes. And what do we call our test scene? We didn't call it anything because it's not in there. Bring it up here. Model view scene. Perfect. So which means we can then initialize one of these. Someone will tell me off because putting it up here and not putting it part of the engine, but I'm going to remove it later, so it's fine. What's it called? It's called model view scene. Yeah, model view scene. We need to do that. Underscore scene. And then we should have a model view menu scene, which we can just call M underscore menu. Boom. First, Adam has just said that it's too late. He has an engine already. It's the world's first AI-assisted design engine, and that's funny. And I could play on that one for hours, because I do think at some point it's going to be available. Maybe if you have, oh, I still don't even think ChatGPT 4 is up to it. It's good at sometimes, but sometimes it just doesn't get things right. But I think some point soon we're going to be able to get to that stage where we're just going to say, ChatGPT, make me my entire game engine. I want X, Y, Z. This is my design requirements. Make me the entire thing, and it would just go boom and do it for us. And then, where are we in terms of jobs? If you can just do that, we'll still be there, I think, because we'll have to debug all the things that the AI gets wrong, or fix it if it breaks. I don't know. From my experience, you need a coder to be able to build code in ChatGPT. I still don't trust it. I will be more than happy. I think, as I say, I think I'm getting a GitHub Copilot license at some point for free for work. So I don't want to pay for it right now. When I get it, I will try it to see if I can just type it in. Don't you need a paid subscription for Copilot? No. Sorry, the chat is going quite crazy over there. I really love the fact that you're all getting involved, but it means I'm having to read it all. Maybe I should stop doing that and just get on with coding. Mscene equals new. What do we call it? Model viewer. View scene. Boom. M underscore model view menu scene. M underscore menu equals new model view menu scene. Yeah, I tried to get it loaded. Speak to me on the Discord if you know a way that I can get it all loaded up free. And I'll look at it into it after the stream. Right, okay, so we've initialized our 2 new scene classes. They don't do anything at the moment, but what we're going to need to do now is we're going to need to add our scene. Let's come into here. So these are our scenes. Let's make ourselves a new scene variable and call this one m underscore current scene. Let's make that null pointer right now. And what we're going to do, basically, from this list of scenes, we are going to just iterate over them, changing which one we want each time. In our add scene, I'm going to add another function here, and I'm going to say bool change. So let's say is current. Bool is current, and let's go in and change that. Do I have that here? No. We just want bool is current. And we say if is current m underscore current scene equals scene. There we go. So that way it gives us a way so that we actually know specifically what scene we are loading up. Let's go back to our engine class. Now the idea technically is that I would like to be able to do this in here, which means I'm probably going to want to do that. Bring that to there for now. So yeah, so what I would like to do is I would like to be able to do this in this class, and this means that from our actual game files itself we can add a new scene, but I'm not ready to do that right now. There we go. So let's just do that. I'm going to come under here and I'm going to say window, and we want to load scene. Perfect. If we are shutting down, we want to unload scene. We've got a scene. Let's now add that. So let's go. After we initialize the application itself. No. before we initialize the application itself. Because again, we would normally be doing this in initialize. So I suppose it doesn't really matter if it was above or below, but I'm going to put it below for now. M under or application, add scene, M underscore scene, M underscore application, add scene, M underscore menu, and then we can just call true on that. Can we call true on that? Too many functions in the call. That is strange. I thought I put that one in one. Equals false. So as standard, if we don't include the actual Boolean array, we're not going to load scene. So the idea is that this loads scene. Right, okay. Add scene, change scene. Let us right, we're pretty good here in our scene. So let's have a look. What do we need? Go to our load scene class. Why do we have this here? Just gone quiet for a moment because I'm just getting to the point where I'm thinking, how do I want to proceed next? I could put the UI in so that we could change windows. I could put a full initialization of DirectX in and have a nice movable box right now, or we could take our time and we could take it one step at a time, get a triangle loaded up so that I can explain it a little bit better. I suppose as this is a tutorial channel, we should probably slow it down slightly, and let's just go in for a triangle. Let's go for a triangle. It's good to see you, Zachary, lightening up the chat over there. Do we want a triangle? Do we want a triangle? I'll tell you what, we're going to leave the triangle for when I come back and do this program, this tutorial series properly. While we're on this live stream and we're feeling a little bit crazy, I'm just going to skip all the way to the end and get us a fully working system working straight away. Always good to see you, Zachary. I've gone a little bit quiet because I know in a moment I'm about to put 10,000 lines of code down to get this working. So I'm just taking a moment to myself just to get myself ready, and then we will start building a full DirectX 12 scene. Idea being we load up all the shaders, we build in the constant buffers, and we get ourselves at least a box ready. Yeah, let's go for it. But give me just 2 minutes so that I can get myself ready for that. Thank you very much for your patience, everyone. I just needed a moment to myself just to get everything wood there and ready. Right, okay, so let's have a look at this. So we've got our load scene item now. What we're going to need to do is we're going to need to first take into consideration what items we have in the scene. The example code that I have here in front of me does not do this. So what I might do is I might build this a little bit backwards, just copy the example code just so we can get something working and then just rework it afterwards. Or I might just play with it. No, I'll tell you what, let's just play with it. Let's just play with it. This is going to be the, hey, hey, hey. How are you doing, my Russian friend? How do we say hello in Russian? There we go. Sorry, they just vented the air for a moment, and I lost all voice in the room. That's one of the problems of living on Mars, I'm afraid. Right, okay, so we are, I promise we are resetting our... First thing we're going to do is we are going to reset our command list and our command allocator. So let's go reset. Default allocator. What did I call it? Should be called default allocator, but let's have a look. What do we call it? Direct allocator. Привет. Okay, I probably massacred that, but I hope you feel the sentiment. We need to take a command list. We need to reset our default allocator, which is our command allocator, and then we need to reset our pipeline, which we don't have at the moment. So just put that as a null pointer. Ta-da! You don't need to tell me off. Default direct. Okay. The reason we're doing that is because we are about to make changes to our DirectX setup. So we want to make sure that everything is reset before we do it. A bit like we did with our resize function. Let's have a look to see how we are doing this in here. I'm going to start by building our cube in here, and then I'm going to put it into our scene afterwards. I don't think that's what I'm going to go back on. I think I'm going to do it that way. So let's build ourselves a new function. Let's just say create cube. Let's just put it here in the window. Create cube. Create cube. Yeah, I know what you mean. No is the answer. No is the answer for multiple windows. The question is, will the engine support multiple windows? And the answer is no, because this is a public engine. I'm doing it for you guys as well as for me, and it's a whole different build methodology. Same as Umdanars, do I put in multi GPU support? Because I can do it right on the bat from the start. And at the end of the day, I came down with the decision of to make a basic engine, you don't need any of this stuff. So we're just building what is needed, really. And then if we ever get this finished, which building an engine is a years-long task. So if we ever get this finished, then we can work on more advanced things later on. Maybe we can do a rework. But yes, no, the answer is no, we're not going to support multi-window support. But it's quite easy to do. You just need to assign your a swap chain for each window and a command allocator for each window. So it's pretty easy to do. You can use the same device. You can use the same command queue and command list in general as well. I believe command list. Anyway. create cube. First thing we're going to need to do is we're going to need some vertices and some indexes. Now, I have got Frank Luna's examples code above me, and I am not going to write all of this out. Let's have a look. That's colors. That should be. That's because we need. We're just putting this DirectX. Cool. We are using DirectX, and a lot of the DirectX functions need that. I could have just written DirectX in front of all of these, but it's easier just to mess it out. Vertex is undefined. That's because we haven't drawn anything. We haven't drawn anything yet. That's why I don't have a vertex variable. Makes sense, but going on the fact that I've been coding a an engine all week off camera, I'm still a little bit confused. So let's come into here and let's put our vertex variable in here. So, what is a vertex? A vertex is a point. Okay, a singular point in space. A triangle is 3 vertexes, and we can tell the system to take those 3 vertexes and turn it into a triangle. As well as being a position and a point in space. So this is our point in space. This is our point in space. Its position is its point in space. As well as being a point in space, we can also tell the engine what color we want it to be at that point in space. So this is this. Later on, we're not going to use color. I mean, we might do. We might just leave it in just so you've got default color if there's problems. But generally, you'd have normal maps, texture maps, shading, etc., that you would fill in this vertex. So you wouldn't actually generally have this color. We'll add it in later. But yeah, this is a structure for our vertex. With DirectX 12, you have to tell it everything you're doing. If you want to make a position system that has 3 variables, which every position system has, then you need to tell it that's what you're doing. So yeah, let's move on. So, hey, vertices, what's going on with you? Variable is not initialized. What local variable is that? If I come into Ether, pretty sure I can get away with rewriting that into a list, but I'm not going to. It's in arrays. Let's not rewrite the wheel here. Okay, so we have got all of the points for our triangle. So let's just work this out quickly. So this is left, bottom, back. Left, bottom, back. This one is left, top, back. If it's plus, it's obviously the higher number, so right. If it's minus, it's obviously left. That's how I can work these out so quickly. So right, top, back. Left, bottom, back. So that's all about back. That's our entire back triangle there, square there. Right, bottom, back. Right, bottom, back. Left, bottom, back. Left, top, back. Right, top, back. Right, bottom, back. Left, bottom, front. Because we're doing the front queue now. So left, top, front. Right, top, front. Right, bottom, front. Okay, so these are our vertexes. I'm going to be nice, and for anyone who is not an expert at DirectX 12, I'm just going to explain how this works, okay? Let's just grab paint. Okay, so at the moment we've got two triangles, one here and one here. The system can work out these points that we've just put in. So we put in this point here. Can I make that bigger? Yeah, I put this point here, this point here, this point here, this point, this point, this point, this point, and this point. And the system is clever enough to know that we want to create that one like that, that one like that, that one like that, this one like this, and carry on. So I'll just put another one in there, and then we should have another triangle up here. And there, and this is how the system is working out all of this information from just these points, and we can tell it to do it as a triangle list, which is what we're going to do at the moment. So we have put just exactly the point location and the colours of all of these sections. How does the system know which? How does the system know in which order to put the points together? So this is called an indices list, and this is a list of indices, or a list of how we want to put the triangles, the triangles together. So first we're going to take the first point in the list, take the second, third, take the first, third, fourth, because it's always things. And this indices list is then going to make up our triangle, our cube. Why don't we just give it all of the exact locations, first triangle, second triangle, etc. This actually makes it quicker. So this is a vertex list, this is an indices list. I probably should explain that to everyone who already knows that. If you didn't already know this, I highly suggest going and doing the OpenGL trials, tutorials first, because they're a lot easier to learn, and you learn all this stuff with it. Render window is the renderer. I completely agree with you, Burns. The question is, why are we loading the scene directly in the render window, and why is DirectX not separate? Linking. I think the best way to do this, and the way I would like to do this, is have the device in one class, the swap chain in a different class, the command objects in a different class, the frame resources in a different class, which makes sense, but then I have to link them all the way along the line, and then we have to pull the this way it's all in one class, and I can pull in everything I need in this one class, and all from protected or private variables. So the main question is, why is it not all separate, is for linking reasons. Yeah, I completely agree. In normal terms, it should probably be done in a different way, but this will work, and that is the main point. So right, what we need to do now is we need to work out how big our vertex size is, okay, and how big our indices size is. So let's just create a uint, and we're going to say vertex array. It's not. It's the vertex size in bytes. Yeah, or it should be vertex array size in bytes. So this is going to be a uint. I'm going to take all the vertices we just made, the size. So that says that we are going to say 1, 2, 3, 4, 5, 6, 7, 8 vertices. And then what we want to do is we want to take this in actual memory size. So we're going to say size of, and then vertex. That is saying that what we want to do is take the memory size for one vertex and times it by 8, because we need 8 of them, and then this is going to be our vertex size in bytes. And let's do the exact same for our indices. So indices size in bytes. Uint indices.size. Again, there's a lot of them here. That's 3 times 1, 2, 3, 4, 5, 6. 6 times 6, 36. 36 of these. Times, and this time we're just going to now again, this is nothing revolutionary. I am pretty much just copying this from an example at the moment. It's not even my example, but I'm just going through it in process and trying to explain it as we come along. Yeah. I mean, I do completely agree. But again, I started this episode by saying I came in here with no sensible plan at all. So that's probably the way it's going to remain. Okay, what we need now is a way to actually store our mesh data. So let's actually create our mesh class. So dx mesh 12 dot dx mesh 12. We need to namespace this, namespace ether. Did we put ether? I don't think we did we? If we did, we need to remove it. Yeah, I did. Yeah, I need to go back and remove all this stuff. Putting ether before absolutely everything just makes your namespace really long, and I'm really detesting it. I think I just changed a lot of this around in my current engine just so it was just directly graphics DirectX 12 or just directly DirectX 12. I think it's that endless thing of science needs to be simple. Like E equals mc squared, which is not simple at all. So it's great. Or what is it? Mass equals velocity time Newton's laws. I can't code and think of science at the same time, but they're all meant to be simple things. And I think generating an engine, we just want it to be that perfect, simple maths equation where we just managed to get it all into one line and we created genius. But sometimes it's best to just not procrastinate and just get on. He says while procrastinating. So let's come back into here. Graphics, DirectX 12. Perfect. Okay, I know, because we are copying pretty much a tutorial at this stage, we are going to need another submesh. When I did this before, I sat there and mapped out the entire program. When I did this last week, I sat there and mapped out the entire program. But I just knew that doing all of the next step was going to be such an in-depth thing that there was no way to map the entire thing without going 5 weeks in advance. So yeah, I'm just roughly going to work on the same pattern I did here. Just start with the basic render and keep just moving forwards and advancing. Okay, again with the Waffle Kingdom, let's have a look to see what we need in our mesh geometry. First thing, let's just give it a name. I'm not going to make these classes. Let's just make them simple structs for now, until needed otherwise. These are structs, aren't I? So that none of these are going to be private, really. Bear with me a moment. My headphones are dying. I just need to put those on charge. I tell you what I probably need. Very loud, obnoxious coding music. You should definitely plan. But I mean, I also have been planning the same engine structure for just years on end. So there's only so much planning you can do. Right, Operation Loud and Obnoxious Music. Check. Operation Get Back on with the mesh. Let's take a... Let's not do that. Let's get rid of the adverts. It's horribly talking in my ear. Right, okay, so what do we need? We need an ordered map, unordered map, and we are going to put a list of submeshes in here. This means if we want a geometry, which is a cylinder with a sphere on top, we can do that and we can make it all into one mesh without actually having to have it multiple different objects for... I mean, it means we can compose and composite different meshes. And we'll just call this one submeshes. Perfect, and then our submesh is not going to need anything right now. That is causing us an error because I put our using namespace DirectX in the CPP. But that's needed in there. It's not though, is it? It's not undefined. Why is that? I'm guessing I probably need a DirectX 12 maths. Is that what I need? No, we have DirectX 12 math. Let's have a look, see what we need in here. So, DXGI check, D3D12 check, compiler check, maths check. And the only one we haven't got is packed vector. Let's have a look. I don't think that's going to make the difference. We've got that one in here as well. Hello, Jackie. How are we doing today? I didn't think XM float needed packed vector. Didn't think I needed that, but adding packed vector seems to have solved it, so I'm not going to question it. Right, let's come back into here and let's have a look. Where are we? Yeah, we're in our render window. Don't have mesh. Let's include this. Let's include this in here. Yeah, if I was to do this again, Burns, the comment was we liked how the Windows class is separated into its own namespace. I think if I was to do this again, I would like to separate everything into their own namespaces and do exactly how you are describing, because I do feel that there's render window really is just a conglomeration of different classes that don't need to be together. But it works like this, and we're 4 or 5 streams down, so let's not change it now. Where are we? We're making a cube. That's what we're doing. Right, okay. Why do I not have mesh? Did I just add that in? Yeah, I did just add that in. Why haven't I got that? Mesh is in here. Graphics, DirectX 12, struct, mesh, struct, mesh. There's nothing wrong with that. There's nothing wrong with that at all. Mesh, mesh. Am I getting linker issues here? Ah, we're not in DirectX 12, that's why. Okay, that's fine. So what we need is DirectX 12 mesh. There we go. Call this one mesh. And let's make this a unique pointer. Initialize our new cube mesh. My keyboard is causing me grief tonight. Bash, and we'll just call this right. Okay, let's have a look. Where are we on chat? Yeah, I get your point. I think, again, definitely engine structure is something that you could do in a billion different ways, and it is very much down to personal preference, and there's always ways you can make it better. But I do agree with most of the things you're saying. For example, if you were having Linux and Mac in here, then I definitely think it would be a good idea to have all separated and platform, not Win32. Where am I? We're going to our mesh class. In our mesh class, we are going to need to add a few things. So, what are we going to need to add? I like the way this tutorial does it, but there are some ways that I would like to. I'm changing it slightly as I go along, so it's a challenge to know which ways I'm adding and which ways I'm not. You've mentioned events a few times, Burns. When I need, yeah, I did build an event class, mainly for the UI. Just so I made a button event class, but that was because I needed it at the time. Again, if I need it, I'll get to it, and when I need it, I'll get to it. Yeah, it depends what you're trying to do, though, Jackie. I mean, if you're trying to get something out onto the market and you want to give it full support, then obviously that's one consideration. If you're building a game for yourself or for your viewers, in my case, then that's a different consideration. So. Right, okay, so what do we need? We need a blob. Let's get a com pointer. We need 2 blobs, in fact. Someone gets 10 points in the chat if you can tell me what blob stands for. I've spent all weeks, Burns, working on this renderer to try and get it to a level where I'm happy with, and I've not needed events once. So again, it's not personal. It's just I just get very single-minded on what I'm working on. So trust me, when I've also got a very good memory. So as soon as I think of the word event, other than just writing a crappy little button UI event, then I will come to you. But yeah, again, I just haven't needed it, and I've been trying to balance things. Right, okay, so we've got a vertex blob and an index blob. Basically what this is going to do is this is going to remember the details on our CPU before we send it over to the GPU. So this is going to be our CPU information, and then we'll have a direct resource for our CPU. Let's go back into our render window. Okay, so we want to create these blobs that we've just made. D3D create blob. Vertex size in bytes. Hey Melon, how we doing? Good to see you. How are you today? How was your day? What are you working on? All of the jazz. So cube mesh, and then we want vertex blob. Okay, so we're going to create our blob on that section on this cube mesh. What do you mean by binary large object, Burns? What did I do here? Why capital void? Because it's just a naming preference. Generally with W strings, you use int instead of int, or floats instead of floats. Double instead of double. It's just a newer way of doing it. They're macros. You don't need to use it. I just prefer it. No other preference. And instead of saying standard W string, I also match that with W string. Just a preference. It just helps me. I kind of get the feeling that it helped me remind me that those are built-in variables, and they're not something I made. Blob is a term for Microsoft. Microsoft uses blob for everything. Well explained. 10 points, Melon. I'll tell you what, I'm feeling generous. You can have a whole 15 points, but don't tell anyone because you're ahead in the points system right now. Right, okay, so what have we done here? First of all, this line creates our blob. We need a blob to be able to fill it up with information. So this line, first of all, creates the blob. We take the blob, they take this blob, and we tell it to create it at this size. Secondly, we need to fill that blob. We need to take our blob, the vertex blob, we need to get the pointers to the buffer, and then we are going to put our vertex data in here, and we are going to again feed it the size. So this is just basically us storing on the CPU what we've just made. Ah, binary large object. I like it. Thank you. We're missing a B. Binary large object, bro. Bro. Right, okay, so we did this for our vertex buffer. Let's do it for our... but anyone who is saying the vertex size in bytes is a terrible name. Blob of junk. Body. Binary large object body. Well, what am I doing? We need exactly the same thing again, so let's not beat around the bush. Let's just start coding. What is your problem? Okay, blob. I think I'm going to go through, once we get a little bit more advanced, I think I'm going to go through and just go back all over this a lot slower with preformed answers in front of me. What does blob stand for, Adam? We have got binary large object, something that Microsoft just calls everything. What is your bet in this? Although I will say that Melon has already won the 15 points, so there's no more points on the table, I'm afraid, guys. Right, okay, we have taken this information, we've actually stored it somewhere on our CPU. So let's have a look. What else do we need to do? Let me pause my music for a moment while I get to the point where I'm going to explain what we're going to do next. So, to be able to upload anything to the CPU, the GPU, we need a buffer. There are multiple forms of buffers available, okay? And you can imagine these as the minecarts that go backwards and forwards from your CPU to your GPU. We can use a dual path buffer, so one that goes from the CPU to the GPU, and we can keep updating it over and over and over again, which is more like an open buffer, and this is called an upload buffer. This is for example, if we want to update a wave pattern over time, we could use an upload buffer, and we could continuously update the vertexes every time we want to actually update the object in the scene. Or we could not do that, and we could just say one time that we wanted to just give it the information and not have to keep on updating it. So there's two types of buffers available that we're going to talk about right now. One is called a default buffer, and one is called an upload buffer. But basically the way this goes is a default buffer allows you to just initialize it once and it will stay set, whereas an upload buffer allows you to continuously updating it every frame. Obviously, both of them are very useful. Upload buffer takes a lot higher of an overhead than default buffer because you have to keep on making that chain every time. So we use our upload buffers sparingly, only for things we need. So in this case, we are going to create our box geometry. And we do not want our box to turn into a triangle. We don't want our box to turn into a sphere. We want our box to always remain a box. At some point we're going to rotate it, move it, scale it, but no matter how much we do those things, our box is always going to remain the same. So we're going to create a default buffer for this. We're not going to create an upload buffer so we can change it every time. We're going to create a default buffer. I hope everyone now knows the difference between a default buffer and a default buffer and a upload buffer. Right, okay, let's come back to our mesh object. This is storing out information on the CPU to be able to send it to the GPU. But what we're going to need to do is we're going to need to create that buffer to send it to the GPU. So let's create this. This is going to be... One moment, I just figure out exactly what I'm meant to be using here. A double buffer. Default buffer and upload buffer are the official terminologies. If for any reason I've got that wrong in people's heads, then I apologise. I just thought it was a good analogy. Right, okay, what do we need? We need an ID3D12 resource. Blob Job. Isn't that a character from James Bond? Blob Job. And let's just do this again. Okay, so we've got our vertex buffer and we've got our index buffer. Again, we are going to create default buffers for these. We are not going to create uploads, but this is what they are actually going to be. And they all form of buffer comes as a resource for the GPU, which makes sense. It's something we're giving the GPU. Okay, it's a resource that the GPU can use to actually render the scene. So everything that we send to the GPU will come with this. This includes the visuals. This comes to do with the position updates, advanced shaders, compute shaders. Everything comes under a resource. Okay, come back to render window. I think I'm going to be definitely on tomorrow night finishing this up, because at this rate we're not getting through anything. Now there is a actual function in here that will help us to create that default buffer. So I think I'm just going to copy and paste that one across instead of going through that one map line by line. Yeah, absolutely, Jackie. I was just reading through the the messages, just trying to get out for a moment. And yeah, I will go into that in a moment when we are creating the actual default buffer. Okay. Jackie's point here is that we will always need an upload buffer to be able to create a default buffer, which is true. We'll go through that in a moment, but then you can go quickly get rid of that upload buffer, change it into a default buffer, and then from that point afterwards, for every consecutive frame rendered, we're only using a default buffer and not an upload buffer. Great point, Jackie. I will go into that one in a moment. So, vertex buffer equals, and then we just want our create default buffer. So we need a create default buffer function. Let's come into our DirectX utilities. We're going to make an inline function. We are going to call this one. First of all, we need to return a COM pointer of a resource. So ID3D12 resource. Create default buffer. Yep. Right, what do we need in this? What do we need this? Right, okay, I said before that I was just going to copy and paste this over. So let's copy and paste this over, look at it in a moment, and then change it around because there's certain ways I don't like how it's working. Oh, I tell you what, we could probably just keep it pretty much as it is. Again, let's just give dedication where that dedication lies. This function was created by Frank Luna. It's not owned, but we're going to go through it. For creating a default buffer, first thing we need to do is panic, as I've just realized the amount of L values that I need to fix in this. First thing we need to do is we need to create a type of upload buffer, and we upload that with, yeah, first of all we create a default buffer, then we create an upload buffer. I'm dissecting someone else's. Again, Frank Luna. Yeah, I mean, Frank Luna is the G. He is the only person worth speaking about, really. Yeah, tell me a better resource for code than Frank Luna. Again, I don't always agree with the way he works, but I don't think. Why is it deprecated? Why is it deprecated? Where is better? I mean, again, I've already upgraded some of these. I would love to have these conversations with you guys. But let's definitely pick these conversations about deprecation, about extra functions up in the Discord, because this is something I would really like to take discuss in more detail, and I'm not really shouldn't really be doing that on the actual stream while I'm live. So let's have a look. So what are we doing? We are resourcing. Ugh, there's so many. This is horrible. Yeah, okay, if you're searching for OpenGL, it's new. But where is the modern, newest versions of DirectX 12? Apart from the MSDN and the examples of the mini engine, which I base most of my code on anyway. Yeah, I mean, the MSDN's got to be updated, though, surely. I do agree that a lot of this is out of date, but it's really not. It's really not. There's a few, from what I can see in general, there's a few extra debug calls, and they've made a few extra functions on some of the updated. It still works fine. I mean, it's not like the code doesn't load if you've got his book and you download his tutorials, and somewhat well as well. I mean, I think anti-aliasing is not working correctly. Right. Okay. So let's have a look at this. So this is, yeah, yeah. First of all, I'm going to have to update all of this. So, auto default heap equals, I think I may have explained how to fix all of this last week. I even have this all fixed somewhere. Default heap auto default buffer equals buffer default buffer. Let's do the exact same thing for Just trying to fix all of the errors as we go along. Why? Why are you giving me grief? What have I done wrong? There's a conversion from corn pointer to... Oh dear, that does sound... does indeed sound scary. Why am I having issues here? Is it because I've got this twice? Ah, I get it, I get it. So this is the default desk. This is the default desk. That's because I've already got a variable for default buffer up there, and that's much better. Okay, so let's do this again. Let's just copy and paste this across. Upload. Yeah, I'll probably just keep that one. It doesn't change, does it? So we can just keep that one the same. So this one needs to be default desk, and this one needs to be upload heap. I just didn't actually change the name. Upload heap. There we go, no errors. Fix that L resource issue. I'd love to just make I've already made the other engine I've been working on for the benefit of this. I've already made just accesses for all of these things like transition. But I haven't done it here, so I can't use it. That's the kind of the rules of the game. And I do think this is important. If you want to use modern C++, C++.21, you need to know how to fix all the L values issues. So this is unfortunately handy. Change that over to there, use it again. Right, okay, here we go. So we create a default heap, we create an upload heap. We use our deep upload heap to transfer our default heap, and then we don't kill our upload heap according to this. Let's get rid of all this. Right, okay. My graphics card is actually really quite old. So quite a lot of the newer functions I haven't been able to do yet. Would love to upgrade the graphics card, but feeding the children has unfortunately always been more of a necessity. What do we need here? What do we need here? Yeah, unfortunately, well, not unfortunately so, I love them to pieces, but it does make spending all your money on new computers slightly more challenging. But, right, okay, so let's not get that. Because these are in pointers, because these are in com pointers, I need to actually get the actual variable, not the com pointer. There we go, create default buffer. Well, you wait until you have children of your own and accidentally say, unfortunately. I think one of the joys of having children is that they don't all often follow in your passions. So I definitely don't think they're going to be watching any programming tutorials. Possibly so. If you're their kids, hey, I hope you're learning. Indices, indices, and index buffer. There we go. Why have we got red? We don't like red. Yeah, I would. Yeah, I would love it. Can you imagine having 8 kids? Not that I'd ever want 8 kids. When you have eight kids that all love programming, you'd have like EA in a week, wouldn't you? But no, again, I think there's a line from June that says the children are always going to be the absolute opposite for everything you are. Right. Okay. So let's have a look in here. First thing we're going to need is we are going to need a few more variables in here just to remember how big the variables are that we are using. So let's first of all get our going to create a uint and we're going to call it vertex stride. Stride meaning the amount we need to move forward each time. Like a stride of walking, I suppose. And then we'll vertex buffer stride. And another one for our index. So these ones are size, not stride. Vertex buffer size, index buffer size, and vertex stride. I think that will do for right now. Let's fill some of these in. So, cube mesh. That's brilliant, Burns. I think my father used to learn to code. I think a lot of our fathers just learned to code. I think it's especially people of my generation. Um, it was a new and crazy thing once upon a time. Now it's just that boring thing that us tech geeks do. So what do we need? We need our vertex stride. And we're just going to make that the size of a vertex. Okay, so size of vertex. If we were to add more on, we just need to add more vertices on more cube meshes. Say we wanted to add 6 cube meshes in a go, then we can just use the vertex stride to increment. We now then need to store these sizes, so our vertex size in and our index size in bytes. Let's store that now. Yay. Vertex, not index. Vertex buffer size equals vertex size in bytes. Now, I probably could have done a lot of these if I just copied and pasted everything in, but I don't think that's quite. That's not what you came here for. Although it does seem to be taking a very long time doing this. Okay, so Let's go back to our mesh and let's discuss this. As I said earlier, what we're going to do is we're going to take this as our overall mesh, and this is going to be our individual meshes in between. Okay, so this is going to be our bunny rabbit, and our bunny rabbit is going to be made up of two spheres, 4 cylinders, and whatever shape you want to make the ears out of. Okay, so we need a different amount of sections in here to be able to say how much we need to increment by over every submesh. So let's just add a few more in here. Good luck with your 4th period session, Burns, and I hope to see you soon. Again, if you've got any feedback, please put it on the Discord, and we can talk about it later. Not entire functions you've already written. Entire class patterns. That I can't guarantee to get into quickly. Index count, index start, and vertex start. I think that was another asteroid coming down there. I'm getting a lot of those tonight. Okay, the amount of indexes we've got, the amount of where in our array of data the indexes start, and where in our array of data our vertexes start. So let's come and put this in here. I would love to say that let's create this new submesh. Submesh, box submesh. I would love to say that once I've created this box and finished off this function that we would be able to see a cube, but unfortunately that's nowhere near true. We have a lot of different items to add before we could ever actually see this, so I don't expect us to actually see anything until possibly tomorrow evening at the earliest, possibly next week. So I apologise for that, but all good things come to those who wait. Let's have a look. How did I initialize these in the first place? Just using a straight submesh. I don't like doing that. Let's go back into here. Got way too many windows open. Let's close. Save that. Close everything apart from this one here. Close other tabs. There we go. And then we can just open up our mesh. Equals new DirectX 12 submesh. No intro variables. And then we say index count equals indices dot size. There we go. That's the amount of indices. And then we only have one submesh, and this is the first one, so we can just say 0. Yeah, I'll tell you what, I might have been able to finish the triangle tonight. Improvement in speeds, mainly. Improvements in speeds, because it's lower level, and I don't actually know enough about DirectX 11. I never really worked in it much, so I don't have that direct comparison. But yeah, I know that DirectX 12, you write a lot of it yourself, and by doing so, you get rid of all of the extra fluff. You tailor it exactly how you expect your program to work without all of the extra overheads. For example, DirectX 11 has a device context. We were doing that in the last episode when we were loading up Direct 2D on it, on our engine, and that device context does a lot for you. But again, it's very rigid and it doesn't work. It's a lot more like OpenGL, whereas this, if we are creating a vertex and it has three, or if we're creating a position variable and it has 3 points in it, we need to define ahead of time that it's going to have 3 points in it. It's got to expect floats, etc., etc. Whereas a lot of the other engines, including DirectX 11, you can pretty much just go, this is an object, please render it. Which means we spend a lot more time setting it up, but spend a lot more time setting it up, but better overheads. We call it. What do we call this one? Cube. We called it a box. Let's call it a box. This is an L value. Right, okay, I don't know if anyone else agrees, but that's way too long time just to write this simple function. So I think for the rest of it, I'm probably going to be copying and pasting a little bit more. These are our vertices, the 4 dots at the back and the 4 dots at the front. This is the indices that tells you how to go through them. Our size is the vertices times the vertex. The indices is indices times uint 16. We create a mesh object and name it name. Why did we name it name? Let's name it box. So this is the box. So let's do this properly. This one's let's call this my player. My viewer object. There you go, my viewer object. So this is actually a the object that we want to view, and then this one down here is the box object that we've added to the my object viewer. Sorry if that made it more confusing. I was trying to make it easier to understand, but maybe that's just made it even more confusing. So we've created our cube box. It seems to change every 2 minutes. Let's have a look, see what else we should do now. We need to in our engine previous to current, did we? Let's have a look in here. No, we don't. So we in our original engine build, we added the heap descriptors for the render target view and the depth stencil view, but we're going to be adding a constant buffer. Now, a constant buffer, again, is a buffer, so this is one of the minecarts that go backwards and forwards to the GPU, and this is going to take in a constant string of user-defined data. We can use that user-defined data to change how the renderer or the GPU actually renders its scene. So, for example, what we're going to be doing today is add a world view object to our mesh. Okay, and in form of a matrix, and then we can use that to update the position, the rotation, and the scale, and then we can actually tell it to do that by using our constant buffer to send information to the GPU, which will send constant information of the world data to update our mesh. So let's create that now. So what do we need for that? Let's first of all, we're going to need one of these. Let's grab 2 of these, in fact. Let's go heap constant buffer view, descriptor size, constant buffer view. Let's just copy and paste this in here because let's not put this in here. Let's not put this in here. I'm going to keep that information, this information here, in our original class. But I think I'm going to put this in here because we are going to need to create one of these per scene that we are loading up, and that because we're going to need to take into consideration how many objects we have in the scene. At the moment, we only have 1, which makes it easy, but we do need to make sure we've got the correct loading pattern. So, Create cube is the first thing we want to do. That it means we've got one of those. Next one, void, render window. Build constant buffer heaps. Thank you. Again, let's put this in here. This here should be the number of cubes we've got, which is why I wanted to make sure that we put this after our generation. This entire function here is just an interim function for us to be able to create a cube, but that should be, the cube creation should be done in the back end, not in this class, in the mesh function, and that should be actually initialized in our scene class. And then when we load the scene, it should be able to take all of the information of the objects and actually load them. So we're going on the idea that when we run our load scene, we already have one object loaded into the program. We need to do throw if failed. m_device create the scripter heap. Yeah, I mean, it really does come down to the to that level. I'm one of these people that I'm very guilty for liking to split up as much as possible. And that is generally how I like my code. I like it all split up as much as possible. But I do think sometimes you get to the point where it's not actually readable anymore. And you've got so many linkers backwards and forwards. You have to keep on. So yeah, I think there is a middle ground that you have to meet between whether you create a new class and you don't, and that really is an art style in itself. Let's just steal that from in here. And we just do this because, again, it changes on every graphics card, so we have to grab it from the graphics card to say what size it is. Voila. So we built our heap files, our descriptor heaps for our constant buffer. Let us now go and create. Well, I suppose if we built the constant buffer heaps, we should. Tell you what, I'm going to go and eat my own hat here because I don't like the word build. I always use the word create, and I've put build in here because I'm copying too blindly. So first of all, let's search for the word build, because there we go. You can tell I don't use it much. Create constant buffer heaps. Create constant buffer heaps. Then we should have another one. We should call this one create constant buffer. Like I was saying a moment ago, when you need to declare everything, this is the same. This is a good example where you have to create the constant buffer heaps to tell it how you want to use the constant buffer, and then you actually have to create it. So okay, so what do we need? We are going to need the actual constant buffer itself. It's basically one of these. Saying constant buffer, but a constant buffer is going to be a upload buffer and not a default buffer. So we're going to need to create a new class to be able to, or a new function. I think we're going to create a new class in this case, but a new function to be able to create upload buffers. We have been live for 7 minutes short of 2 hours already. So I think instead of getting immediately on creating that upload buffer, I think I'm going to call it there for the evening and come back tomorrow and hopefully get this finished tomorrow. Hopefully take a lot quicker time coding and less time waffling. Yeah, I definitely think structure is something you need to, in my honest opinion, you need to not be so hard on yourself. Again, you could spend years upon years never actually coding, but just trying to name and figure out the perfect engine structure. And if you know this, then you can try and avoid that, and you can just try and be nice to yourself. No, you're not going to get it perfect, and just try and get some working code. Do think the most important thing, and the last point to leave on tonight, the most important thing when you are building a game engine or building a game is to build a game. And as long as you are having fun and moving towards the point of actually getting a game out of it or an actual objective out of it, then it really doesn't matter if your code is messy, it doesn't matter if it is named wrong, and it doesn't matter if it's completely unreadable by someone else, because at the end of the day, it's for you, and this is why we do this. We are driven by the fact that we want to make a game. And one thing I can guarantee is if you procrastinate forever on engine structure, you're never going to see the game that is keeping you motivated in the first place. And that being said, I am going to leave it there. I will see everyone tomorrow. Thank you very much for joining in. I've been Imperator at Olympus Mons, and have a wonderful evening. Thank you. Goodbye.